Let me introduce myself. My name is Patricia. I've got years of testing, and I would like to say to you that you are in a good place. I'm sure Yemi has given a very good foundation regarding the testing, the manual testing training, and I'm going to continue from there today, and I'm going to be taking the following topics: software development lifecycle, the different models of the software development lifecycle, the pros and cons, the concepts in understanding testing. So basically, those are our learning objectives for today. If we go on, what is software development lifecycle? It is a process that is used by the software industry to design, develop, and test software to ensure quality of the software. So the aim of the software development lifecycle is to produce a high-quality software that meets or exceed the expectation of the customer. So as you can see, the shortened form is SDLC, and we are going to be looking at Waterfall, the Waterfall model, the iterative model, which the otherwise known as the incremental model, and we have the Agile as well that uses the process, the iterative process to deliver software. We have the spiral model, we have the V model, we have the Big Bang model, and rapid application development model. The focus would be mostly on the waterfall, the waterfall model, the iterative model, and the V model, basically, because I think those ones that are basically majorly common in software testing, even though I might be touching some other parts, but for the sake of time, I'll make sure I do justice to those three models that I've mentioned. So if we look at this waterfall, as the name sounds, I'm sure you can see the diagram. You can see those arrows. Pictorially, that tells you that something is coming from the top to the bottom. So the beginning starts from the requirement stage. Now, just to make a note, most of these models have got requirements. They got those stages. Requirements needs. There should be a requirement. Excuse me. There should be design or development. Then testing would come through, and the application goes into the environment. It's deployed into the user's environment, and some form of maintenance goes on there. So typically, the software development lifecycle waterfall model is also referred to as a linear model. And what this means is that at every phase, there must be completion. You complete every phase, and then you move on to the next phase. One thing to note is that for each of the phases, the goals of each phase must be defined. Take, for instance, we start from the requirement phase. At the requirement phase, some analysis is going to be done. Requirements are going to be gathered. They're going to be documented. They're going to be analyzed. Most times, this is the work of the business analyst. They gather the user or the business requirements, and they define them, and they get those signed off by the user or the business. So when I say user or business, please try to understand that I mean the same thing. So after the requirement phase is signed off, then we have the design phase. This is the system design phase. So the system design helps in specifying the hardware and the system requirements, and it helps in defining the overall system architecture. So that is a phase where maybe the project team, they probably have a solution architect in the team, they have a designer in the team, and then they come together. The business, maybe they have they arrange the business analyst is involved. They arrange a design meeting, and they agree on the system design, and they get that signed off. Then the next phase is the development phase. Some other name you could call that is the implementation phase. So that is where the code is implemented. So the code is written here. This is where the code, whatever language the project team or the developers choose to write the code, this is where it happens. So all the requirements that have been gathered and signed off together with the design, everything starts to come to life in the code. The developers start to write the code in small units and they test them. Once the development is completed, we move on to the testing phase. In the testing phase, this is what concerns you and I, you potential testers, or maybe you're already in the testing industry. So at this phase, we have a test plan, a test script. All we do basically here is to commence testing because the development is completed and signed off. All the testing we need to do around in this area, that is where we do it. If we need to have a user, then after the system testing here, we just have the user acceptance testing, and we sign that off. The business signs it off, the users sign it off, they are happy, and all that. And when we finish the testing phase and everybody is happy, it's signed off, we move on to the deployment phase. So this is where the system is deployed. Here, all the functional and non-functional testing is done, and the product is deployed into the customer environment or released into the market. So at this stage, the next phase is the maintenance phase, where what is required here, perhaps the customer, they need to make a change at some point, or they have an environment issues. That is where the IT support team come in. And if anything is going to come back at all, it might be a bit costly if it's a major issue. Even if we find a major issue before we get to the deployment phase, and that is one of the cons of the waterfall model, because we need to complete a stage before we move to the next. If something goes wrong in the later stage, there's absolutely no chance of going back to fix that, because these things have been signed off and we've completed testing. It's an expensive model. It could cost a lot of money to do that, because it will cost some money to go back all the way and make a change. If we want to look at it from the positive side, the phases they're in processes, they're in stages, and they're completed one at a time. That looks like a very organized development process. But I think basically from other references I've looked at, Waterfall Model works well for smaller projects where all the requirements are very well understood and there is no likelihood that a change will be needed. I'll move on to the V model software development lifecycle. As you can see here, it is also referred to as a sequential development model. For every single phase in here, if you look at this diagram, it looks like a V shape. So you can't get it wrong. You see this diagram, you know this is a V model software development lifecycle. From the user requirement stage to the software application stage, which I've explained earlier, like I would say you have all of this similar there. Requirements are gathered here, the system design happens here, an architectural design, the high-level design. Then you get to the detailed design where we proceed to the coding. And at this point, each of the modules are designed here, and coding starts. One thing to note is that on the left side here, some verification takes place. And in parallel, you can see the coding joins everything that is happening in validation with the everything that is happening in verification. So everything at every stage, all what is happening at every software development stage is in parallel. It is in parallel. As the coding is being written, the unit test plan is happening, the unit testing is going on. As after the coding is completed, after the unit testing is done, we have the integration testing. That's the type of testing that goes on there. For the integration testing at this stage, the individual units, individual components that have been developed are tested here. So we have the integration of modules, integration of components. You know, this testing happens here where we input the data and get an output from the data we've inputted, and then we move on to the system testing phase. So for the system testing phase, what happens there, all the units developed here, and together with all the integration of the modules developed, all come together into a system. So at the point where we are verifying the system testing, we're actually on our way to say, okay, this software application, we've had a system test plan for that, and we've done the system testing, and we are fine. I'll still move on and give some more explanation relating to that. But two things to note here in this diagram, we have the V model, we have the phases of development where verification takes place, and we have the testing phases that goes in parallel with each of these phases where validation takes place. So basically, the verification answers the question, are we building the product right? It also checks that the application meets the requirement that is set out for it. The validation answers the question, are we building the right product? At the top end of the validation testing is acceptance testing, where the users do this. So this focuses mainly on the needs of the user. So to go have a deep dive into this explanation of the V model. At the stage of the business requirement analysis, the details of the requirements of the software are gathered from the clients or from the user or from the business. Acceptance testing takes place here. This is where the users test. At the software application design stage, this is the stage where the team comes together and they brainstorm on how they want the system to work, how they want the system to interact. There's a decision around that as well on the functionality or the features that goes into the system. So the testing there, system testing, it checks the entire system functionality. If here, for example, you have a system, say for example, you have a website that users want it to be a centralized portal for various kinds of data. And two things the users want: they want to view the data and they want to use the data. But there can be different types of users. So at this stage, so the entire system testing would involve everything that is going to involve getting the right view of the data, getting the right data when testing, getting the right output from the data when testing. You have the architectural high-level design of the software. So I explained this earlier. Sometimes some organizations, they will get a solution architect to do this for them, or somebody who has a very good system analysis knowledge or area, or maybe that's their area of specialism. So it's a high-level technical details. The type of testing that goes on here is integration testing. And if you've heard about APIs and all that, or APIs already, this is where the integration testing comes in, because this is going to involve all the backend components that you can't see. So there's a coexistence that happens between these components that make up the entire system. Now, when you move on to the module or the detailed design, I already explained earlier that just before you get into the coding phase, this is where new codes are developed, new codes are built to satisfy the requirement, because the code has to be written to satisfy the requirement. There's nothing separate going on between the requirement and the code that the developer writes. It has to work together, and that is what ends up as a product, that's gone out to the users. So I got some diagrams out, basically from the internet, so we can have a pictorial view of what we're trying to say around this. So for the iterative and incremental development, so a development model. So this particular model produces an output at the end of the requirement analysis, design, and coding. It produces an output at every iteration. It is an iterative model. Everything happens incrementally. Everything happens incrementally. The requirements are broken down into multiple, standalone modules of software development cycle. So, for example, we want to develop a website, and to keep it simple as possible, we want to develop. I will use the same example. We want to develop a website that accepts data from various sources, and we want users to be able to view the website, and they could use the data that is coming in for various reasons. So, but before users can do this, we know we have a high-level view of what we want to do, but we don't want to put this together all in one go, like the waterfall. What we want to do is to start to build this in iterations. But we know that before the users start to use this, before the users get into this web portal, they need to be able to log in, and they need to be able to register. Okay, register and log in. Yeah, following that process. Now, iteratively, for example here, if I pick iteration 1, because the goal is to be able to deliver a product that is a product that is partially like a product that is partially fit for use. Okay, so but we need to do it in building blocks. So this is where this comes in. The team can decide to say, and agree that, okay, for this iteration 1, we need to start with the registration bit. We want to be able to produce that UI, that interface, that UI at least. Let's have the UI, something to present to the users. So at this stage, they're able to fit the registration as a requirement there, analyze it. How do we want the registration page to look like? All those kind of discussions go into that. They do a design of the registration form, and then the coding starts. When the developers are finished coding, we are expecting a partially developed product, which is one of the building blocks for us to get to the final product, registration. We are able to produce that. And during this stage as well, testing happens. So for each of the iteration, there's an output coming out. We finish that iteration, we look at it, what other requirements can we prioritize? Okay, we now have the registration, then okay, can we implement the login? Then we start another iteration. I'm just giving this as an example. Registration is too small a feature to deliver in any iteration. So depending on how complex the application is, basically. So, and then we move on to login, and we say, okay, that's another incremental product output. Fine. Everyone is happy. Now we have a UI. Users can register and users can log in. Imagine there is another iteration there, iteration 3. If, as you can see, this is iteration N. Iteration 3. Now we want to pull all the data in. So that will be the product of iteration 3. We are getting data. When we log in and we register, we are able to view data. Now, let's assume every other requirement coming. It goes through the iteration phase, and then up to the point where we have completed what we need to do, including testing, and we have a software product as our final product, meeting the requirements, being verified, meeting the user needs, it's being validated. So that is one example. On the iterative and incremental development model. Now, if you go on, I'm sure if you've done your research well, you would also have heard about Agile. Agile employs the iterative and incremental process of development. So sometimes it can be used. The Agile can be used in that context, as like it can be described in that context, or can be used as a development model that is incremental, because that is what happens basically in Agile. In Agile, the requirement goes in as a backlog. It goes into a backlog. The requirements, the big document kind of that we get from the waterfall design. Just imagine you pick that big chunk of requirement document from the waterfall. You keep it close, but from those requirements, you begin to extract your user stories from the requirements. Yeah, that just to keep it simple. You extract your user stories. Your user stories will now form little chunks of requirements that can go into an iteration for development and can produce a partially developed product. That is an example of an iterative incremental development model. So in a simple way, that is Agile. It is simple to apply Agile model development because users want, one of the reasons basically is that the users or the client, they want the product out quickly. So you can have an Agile development model way of implementing any product. You can have that done in a few weeks, and when the client sees it, they know if they want to make any change. So Agile enables changes to take place at any point in time during the development, unlike Waterfall, where once all the testing and development is completed, it is hard. You can't go back to make changes because you've done it and you've deployed it. Anything outside that will come back to the development team as a change request, sort of. But for Agile, that is the end of it. So I'm sorry, for Waterfall, let me correct myself. That's the end of it. It's been done. The phases are complete, and that is it. So if we move on, that's another example. Now, just for you to have a clearer understanding, you see that this diagram has got this description as build. In the other diagrams, it has it as iterations. So it can be used interchangeably. There's build 1, there's build 2, there's build 3. There's a requirement outside of that that translates into a build, and in each of the build, design and development takes place, testing takes place, and there is implementation. Now, across all these modules that we have talked about, there are different levels of testing that takes place there. And we have the unit testing, integration testing, system testing, and acceptance testing. And I think I've explained that earlier here, what unit testing is. It tests the individual modules, individual components, the code the developer has written. That is what unit testing tests. Unit testing is done by the developer. Now, integration testing in the Agile context is done collaboratively by the developer and the tester. So as a tester, you could be the one driving it, or it could be the developer driving it. But this is not as important. You can do the testing manually as well, and you can do the testing in automation. But because we are talking about manual testing in this case, your integration testing, you can do the integration testing as a tester, and the developer can also do some integration testing. But it's just basically you try to understand what works with your team. So, but outrightly, unit testing is done by the developer, not a tester. Then the system testing checks the entire functionality. That's another level of testing. And then we have the acceptance testing, which is done in the user environment. So if we go on to test types, so testing can be functional and it can be non-functional. Now, for functional testing, What you're testing are the features. When I say features, for example, we all go on websites. Login is a feature that can be tested. Yeah? Search is a feature that can be tested. So when you want to test a scenario, you can have when you're testing the user journey, let's say the user journey, because every website must have a user. Now, when the user comes into a website, says asos.com, if you shop on ASOS, or let's say Amazon, yeah? When a user goes onto Amazon, we have billions of users on going on Amazon. However, they can use the system in different ways. Everyone is not going to go on Amazon and buy the same product, but everyone could be on Amazon and they can actually be buying the same product at the same time, but at different locations. So as a tester, when within the functional testing context, you can have scenarios, you can have all sorts of scenarios to cover. You have the positive scenarios and negative scenarios. The simplest scenario, for example, which every tester can use even when you go for any interview. If you kill that, they know you know what you're talking about. Is user being able to log in or user not being able to log in? Then you're creating a different scenario. So the positive scenario in this case is user is able to log in. And the negative scenario is user is not able to log in. So that's simply put forward. Then you can have scenarios testing boundaries as well, because errors usually happen in boundaries when developers miss something, or probably they didn't do their unit testing properly, or the boundaries could be minimum, maximum, all those operators, less than, greater than, equal to. It's just going to be good if you're able to identify what the boundaries are and what type of test you can write for that. And we have the functional testing techniques. Now, within the functional testing techniques as well, it can be a white box or black box testing technique. Now, the white box testing, I think I'll also move on to that. Let me finish with this before I go into the white box or black box testing. So basically, for the non-functional testing, we are verifying. This is usually a specialist area, where if you're a manual tester, it's something you can also pick up and learn by yourself. There are loads of resources that you can look at if you want to learn performance testing. And I think we do have a performance testing lecture that is going to happen on this program. So keep an eye on in the Telegram group for that. So for the non-functional testing, everything that is not that relates to the performance of the website, how robust it is, the stress testing is done there. You can have security testing done there, load testing, volume testing. In this type of testing, you are basically not looking at any feature or functionality. You want to test the stress level of the application. How many users can it take at the same time? When users are going through specific type of scenarios that are kind of repetitive, how many users can this system take before it breaks? So that is it. Then we move on to the structural testing, which is white box testing, basically. Some people call it clear box, open box, logic-driven test, or path-driven test, because you're testing the logic of the application. Now, there's testing after code has been changed. Now, two things can happen. You could, a tester would need to test after code has been changed. Maybe a bug or a defect has been found, and the developer has fixed it. Then retesting of the bug happens there. Or a regression testing happens around the same functionality where the code has been found. So you could either be retesting or doing regression testing. So this is one question that you may get at interviews. You need to be able to explain the difference between retesting and regression testing. Both can happen after code has been changed. But for retesting, maybe a bug has been fixed because you already tested that functionality before, you are retesting. For regression testing, the code has been changed because a bug has been fixed. However, you want to do a regression testing so that you are able to confirm that the code change has not impacted any other functionality negatively. So that is that. And I move on to some basic concepts that we also need to understand in testing. So testing and debugging. We have static testing and dynamic testing. We have testing as a process, and we have testing as a set of techniques. Now, if we look at this particular one, testing and debugging, we've learned from the background Yemi gave. Testing helps us to verify and validate that a software or application is bug-free. It also helps us to identify if there are defects or bugs in an application. And it also helps us to identify a software failure. However, debugging, now that sounds really technical. Never mind. What debugging does is to fix a bug or defect in the software. The process of fixing the bug in a software is debugging. So at the point, debugging is done by a developer. However, debugging from a manual testing point of view would look like you trying to investigate why the error is showing up while testing, or where. You are trying to find the where or why. If you find the where, that is good. If you find the why, that is absolutely fantastic. But the debugging concept basically is what a developer does. He identifies, analyzes, and removes the bug. Can you see? Debugging, removing bug. So when you move on to static testing and dynamic testing, static testing is done when the code is not executed. Yeah? This is where we have review of documents. So requirement documents, when they are reviewed, there is no code execution there. That is static. We all know anything static means it's not moving. It's just staying in one place. So Yemi gave an example the other time, like you have a page that there are lots of text on the page and you want to pick out errors there. What you are doing at that point is static testing. Static testing is also done on a code when the code is not being executed. So there are different ways, there are different types of static testing. Then dynamic testing. This is the testing that is done in the validation stage. At this point, the code is being executed and it is tested without necessarily being examined. We are not looking at the code for any reason. We are just executing the test in there. That we have the testing as the process. Okay, I've got all this here. So the pros and cons of bear with me 1 second. Yeah. So for static testing, you don't need any tool to do static testing. It's just is a review. You do a review of a document. You do a review of a code. You do it could be an informal review. It could be a walkthrough. It could be a technical review. Yeah, so that is static testing. But for dynamic testing, you just execute. You do your testing. Code is being executed while you're testing. So let me give you an example. Say you're on the website. Every action you do on the website, when you click registration, a code is being executed in the background, but you are not seeing the code. That's just a simple explanation. Now, okay, yeah, talked about review. A review is a systematic examination of a document by one or more people. And the aim of the review is what? To find errors. If you remember in the first lecture, we defined error in a software. And you know what? It saves the company lots of money if errors are detected early at the point where you are reviewing the document. Say a requirement has been written wrongly, or it has been captured wrongly by the business analyst, and a static testing has been done there. It's a kind of informal review, and you can easily pick up any issue in the document. And at the end of the day, that particular error has not gone into coding. Because if that error is not corrected, the developer also will pick it up and just code it and include whatever has been written. So it might not be an error when the developer does the code. However, by the time the tester is checking and testing against the requirement and it's not giving the right output, then you know something is wrong there. So I've mentioned, okay, the types of review. It could be walkthrough, technical review, inspection. All this happens. All these are examples of static testing. So I want to go into test design concepts. Now we have what we call a test condition, test case, test procedure specification. Now, what is a test condition? The test condition, in simple terms, is that item within a system, that could be verified with a number of test cases. So an item, a functionality, an event within a system that you can actually create test cases to verify its correctness. So, for example, you have when the user name and password are valid, then the submit button should be enabled, just for simplicity's sake. So the test condition, the feature that you are applying the test condition to here would be the login feature. Okay, so you are able to verify the login feature with one or more test cases. The valid test case here, when the username and password are valid. We all know we use that for login, yeah? Then what should happen? Submit button should be enabled. Simple. If you want to put an invalid, another example, when the username and password are invalid, the submit button should not be enabled. So we can see the condition you're verifying in there and the feature that is being verified. Now, if you look at the test case, a set of actions that is executed to verify a particular feature. Now, those actions would require test steps. It will require test data. It would require preconditions to execute the test, post conditions possibly for you to be able to verify the requirement. Then the test procedure specification, that's your how. How am I specifying the sequence of actions for me to be able to execute the test? So that particular procedure also feeds into your, that is what some of us would describe as your test steps or your test scripts. Because it outlines the sequence of action for you to be able to execute the test. So I've given some specific examples in here. You have the test scenarios to check the login functionality for your website. You've been able to build test cases around that, and your test cases will check that the results on entering, will check the results when you entered a valid user ID and password. That's a test case. Another test case, when you enter invalid user ID and password. Another test case, when the user ID is empty and login button is pressed. And there can be loads. You can have loads of permutations and combinations of valid and invalid user ID and password in this case. Then we have the test condition here. The condition we are verifying is a condition where user ID and password is valid, where we have invalid user ID and invalid user password. Other examples, we have a few minutes to go. I thought I was going to be able to complete. Okay, well, we can continue from next week. So other invalid, for example, with this particular test condition, if you're following me, please, if you have your chat box open, if you can give me examples of other test conditions that you can cover with this particular example. So we have covered a test condition verifying the valid user and valid user ID and valid user password. We have covered invalid user ID and invalid user password. Does anyone know of any combination that you can use as well as a condition to verify that particular scenario we're looking at? If you can, please type that in here while I'm checking for questions. Anybody? So valid ID and invalid password, correct? Valid user ID and invalid password, excellent. Yeah, thank you so much. I know you're all following. Blank user ID and blank password, excellent. Yeah, good. All right, do we have more? Okay, yeah, thank you so much. I appreciate that. Forgotten password is actually a feature. Is a feature that we would also require on a login. For username, yeah, I'm not quite sure I get that for the username. So what we are trying to validate is a login feature, yeah? Is it that you have, like, I think somebody mentioned that you don't fill, when you don't fill any text in the username and password. Okay, valid user ID, so yeah. Okay, so for password reset, the password reset is also a feature. So basically, if you're verifying a login feature on the website, that is different from verifying the password reset functionality. The password reset function is a functionality, is a feature. I know when we have a typical web application, you can see is either you see the forgotten password link or password reset link. So that is basically a feature. But by clicking that, you are not covering the validation that we require for this particular scenario in this context. But the point where your password reset will come in, which I'm trying to understand the angle you're coming from, is that at the point where you do your password reset, you are also able to apply all this. You're also able to apply your login details into the login functionality. Yeah. So yeah, that's it. I hope I made some sense trying to clarify that. Okay, yeah. All right. So have we got questions from what we've talked about so far? The software development models, the waterfall, the linear or waterfall, the iterative or incremental, the testing levels that happen there, unit testing, integration testing, system testing, and acceptance testing. The iterative diagrams, how I explain the incremental model. Okay, I can see a question here. It said, is it possible to be a performance tester or non-functional tester and a functional tester? Honestly, you could be a 3-in-1. Absolutely fantastic. But from my experience, you grow into all of this. Now, I've seen some people that have just gone straight into performance testing, but my observation is that is a niche testing area. So you don't have companies just don't have a project team and put a performance tester on every team. Do you understand? So you either start as a functional tester and you grow into learn about performance testing and other types of non-functional testing. Can we use Agile for small projects? Basically, yes, you can use Agile for small projects. That means that your product is going to be out within days. Absolutely, you can use Agile for small projects. Small project, complex project, but that means your product is going to come out ready within days if you want to go down that road. Can you please explain in short the difference between regression testing and retesting? Okay, I'll explain that again. Now, the prefix is testing. There's the testing as a word and there's Now, when you have the word write, you've written something and you've been asked, okay, your composition is not looking good. You know, our secondary school days, I don't know if any one of you is still writing composition now or any essay. Your teacher would say, okay, you need to rewrite this. So basically, you've already written and you need to rewrite. So for retesting, you've tested already and you have basically, maybe you found a bug. Then when the bug is fixed, you have to retest. You have to test again. Then for regression testing, a feature is already working fine. Our login is working fine. There's no bug in our login. Yeah. And for some reason, one of the requirements that we have for the login is that we want to be able to use passwords with some specific types of characters. I'm sure you must have seen that before. Before, what has been implemented is any type of character with any word, with any letter or any number, alphanumeric, or with any type of character. Exclamation, dollar, colon, any type. But now we want to make a change that for the password, it has to be only dollar and exclamation sign. When the developer applies that change to the login password, that change is only for the text you put into the password here. I'm not only going to text the change relating to the password entry, I mean the password input value, but I'm going to also check the change. I'm going to also do a regression test across the login feature entirely. That is a regression test. All you're doing is the changes that have been applied to the password has given you a reason to do a regression test to check that the login feature has not broken, because the developer has gone into the login feature, which is a parent feature, to be able to apply that password text change. So the login feature could be impacted by the change in the password requirements. So that is what regression testing is about. Now, what is the difference between white box and black box testing? So white box testing, like I said earlier, it is for white box testing, you test the structure. The tester is concerned with the structural component of that system. Yeah. And for black box testing, the tester is concerned with just the functionalities. Whatever is going on in the background is not my business as a tester. All I just want to do is to test the functionality and the features. I don't want to see the code. And mostly for black box testing, you don't need a programming knowledge to do that. But for white box testing, you need a programming knowledge to do that. All right. Somebody is asking for the PowerPoint lesson. I would have to discuss with the director. I'm not entirely sure if we would be sharing these slides. However, please subscribe to our channel, our YouTube channel. Whenever the video is updated, you're going to be able to watch the video over again. Is it fair to say that most manual roles are black box tested? Yes. Most manual roles are. Yeah, the black box testing. You don't need any knowledge of code. They give you the feature you test. Are there types of white box or black box testing? I know white box testing can also be glass box testing or clear box testing or something. But types of black box testing, all your functional tests, basically, all those the user acceptance tests, all those levels of testing that you do, at the acceptance testing level, the testing you do at your system testing level, they're all black box testing. There are some integration testing that would fall into the category of black box, because you are not actually looking at any code. You're testing the integration between components, or integration between systems, how systems are talking to each other. So thank you so much, everybody. I appreciate you coming online for this training, and I do hope you have enjoyed our session. So please, you've got the PDF to the document, to the text, and for the project, for the training, the ICEP project, the ICEP textbook. Please, you need to read, and you need to start preparing for the exam. Please, you need to read. What we are giving you here, mostly we are giving you. We are using the ISTQB as a baseline to deliver this lecture, and you find out that Yemi, from the onset, she started to apply our experience based with explanations, and I'm trying as much as possible to do the same. Okay, what is the name of the book? We do have it here. So the book is here. The first lecture, yeah, that's the book, Software Testing and ISTQB ISA Foundational Guide by Brian Amblin. So the PDF was sent out. People requested for it from last week. So if you haven't received the PDF, please put in an email request, and you're going to get it. You need to read this textbook to all have a very good understanding and background of software testing, and go in confidently to write the exam. There are 40 questions, all are objectives. And if you read that textbook, I'm saying to you, you're practically going to love it, honestly, because everything you need to know in testing, the foundation guide, everything is there. Thank you so very much. Thank you. Okay. Put in your request in an email if you haven't got it. Please, thank you. I need to go now, and we'll see you next week by the grace of God, and have a lovely evening. Bye.